Hello, welcome to the session on layered architecture of networking. So the layered architecture of networking is very fundamental concept of networking and most important concept of networking to understand how networking works. So in this session, we will see what is layered architecture, why the layered architecture is needed, and how actually it works overall by some example. So the idea is basically we want to clear our understanding. So when the two devices or when the two people communicate to each other, how actually this communication happened. So let's see what is layered architecture. So if you look at this simple network topology, so you can see here are several network devices, like you have the PC, you have laptops, we have routers, switches, servers, and they all are connected through the internet. So if the two devices, like one PC, want to communicate to another PC, they have to go through all of these devices, and this whole function and the work done by all of these devices is called the networking process. So this networking process is very complex and lots of things they need to do. There are many protocols, many functions they have to done to send a message from one device to another device. So this whole process is called networking process. So then, to make this networking process simple, to make this networking process more organized, more easy, so the functions of whole network process is divided into layers based on some functions. So like if you look at here, the network process is divided into layers of, you can see the bottom layer, top layer, or layer n plus 1, layer n minus 1. So this layering is nothing other than basically divide the whole complex network process into different functions. So now when we understand that, so what is the layered architecture? Layered architecture is basically divide the complex network process into different functions. So why we need this layered architecture? Number one, we actually want to reduce the complexity. We want to reduce the implementation complexity. We want to reduce the design complexity so that we can implement our networking process more easily. So we also said like the modular engineering, right? So you might, if anyone has understanding on also the programming, you can see the object-oriented programming. So whole process, actually whole problem is divided into, or a big problem is divided into small problem, and we solve all this small problem and again integrate them so that we can get the whole complex problem or complex process get done. And another important part here is in the market we have different vendors. For example, we have Cisco, we have Juniper, we have Nokia, we have IBM. So we have many different vendors developing their devices, their applications, protocols, right? But they all need to work together, because in different part of the world or different organization may use different companies' product. So to establish the interoperability between one vendor's device or one vendor's product to another vendor's product, so the layered architecture is also give us very or layered architecture help us so that one to give the interoperability among the multi-vendor devices. So it can communicate easy from one vendor's product to another vendor's product. So why layered architecture? The first of all, we want to reduce the design and implementation complexity. So we are divided the whole process into different functions, and that different functions we are called, it's the layers. And these layered architecture also give us the interoperability of different vendors in the network market. So now when we divide the whole process into different layers, we have to keep in mind that how actually two devices communicate each other, and how same device but they communicating one layer to another layer. So the same layer interaction is happen when two devices are communicating each other. So that means one computer is communicating to another computer. One computer is sending a message to another computer. In that case, same layer interaction is happened. But if same device or one computer is forwarding a message from one layer to another layer, in that case, adjacent layer interaction is happened. So if you look at the computer 1 in this figure, you can see the layer n can communicate to layer n plus 1, or layer n can communicate to layer n minus 1, but layer n plus 1 cannot communicate to layer n minus 1. So that means within the same device, any layer can communicate to only to its upper layer or the lower layer, immediate upper layer and immediate lower layer. It cannot jump to another layer to communicate. And the two different devices, like in this example, two computers can communicate each other in the same layer. So this layered architecture is also called the reference model. So in networking, we have two reference model. One is TCP/IP reference model. Another one is the OSI reference model. So OSI reference model has 7 layers, from physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. And the TCP/IP reference model has 5 layers. So the application layer in TCP/IP model actually combined the top 3 layers of OSI model. That means application layer in TCP/IP model included session layer, presentation layer, and application layer. So we can get the 5 layers in TCP/IP model. In some of the literature or some of the resources, you might see the TCP/IP has 4 layers. In that case, actually the data link and the physical layer together is called a network access layer. So in that case, they can have the 4 layers. But let's consider now the TCP/IP has the 5 layers: physical, data link, network, transport, and application layer. And the TCP/IP model is actually now is implemented in our networking. So let's discuss more details on the TCP/IP reference model. So let's briefly tell you about the different layers of TCP/IP reference model. So the application layer, which is the top layer and which is closest to the user, like when we use a laptop, we actually work on the application layer. So like when you write an email, when you watch a video, or you do some other works, you composing, you are using the Word. So we are actually working on the application layer. And application layer take all of this user data and forward it to the transport layer. And transport layer actually split this all the messages, all the user data into smaller unit, and it's called the segments. And then the transport layer also do one more thing, is called the support multiple applications. For example, in your laptop, you at a time maybe writing an email, you are listening a music, and also you are doing some other application is also open, like you are maybe preparing your writings, right? So more than one applications we actually use at a time. So the transport layer actually help us to identify, to separate the data of different applications. So it actually support multiple applications. Then the transport layer forward this data or segments to the network layer, and network layer is prepare its own packet, and it also has the addressing, like it's called the IP address. And in other video we will talk about the details on IP address. So what is IP address, how it works, right? And subnetting, VLSM, we will discuss that, all of this in separate video, separate tutorial. Okay. And the network layer also find the best path so that it can forward your message to the network, so that the receiver in the other side of the world can receive it. So the network layer also find the best path to transfer the data across the network from one end of the world to another end, right? And then the network layer forward it packet to the network access layer or data link layer, and data link layer actually do the framing and also do some error control. So this is very briefly about what actually application layer, transport layer, network access layer do. So let's see some of the protocols we have in different layers, just to give an idea. We might talk about different protocols from in different video. Like in this case, application layer has HTTP, then the DHCP, transport layer has the TCP, UDP. So internet layer or network layer has the IP, OSPF, BGP, many protocols. So we cannot cover these protocols in one video, right? So we might need one video for each of the protocols. So we will discuss this later. Just I bring it here so you can get an idea, like every layer has many applications. So how complex is actually the networking, and this is why we actually make layers in the network design and whole network process. So let's have with an example, let's try to understand how actually when a device or when we communicate each other, what actually happen within each of the laptop or each of the device. For example, we have two friends, Alex and Alina. They are communicating each other, they are texting to each other, and we will see how this is happen. So when when the data is forwarding from one layer to another layer, we call it protocol data unit, PDU. So let's see how actually it works. So now we are discussing based on the TCP/IP model, TCP/IP reference model, because the TCP/IP reference model is actually implemented in the networking. So consider Alex is sending an email to Anila, and let's see what happened sequentially in the network. Okay, so when Alex write an email and it's say the send button, so the email or the message actually transferred to the transport layer of Alex laptop. and the transport layer actually divide the message into multiple small part, or multiple, we call it segments. So multiple segments. For example, in this case, consider the whole message is divided into 3 segments: segment 1, segment 2, and segment 3. So now the transport layer take one of the segment and it's added its own information, own protocol information, which is called the header, and together the payload and header. So the information about this layer, information about this protocol is called the header, and the segment it received or it's divided the actual message is called the payload. So the P, I mean here the payload, and H is the header, and together P and H is called the segment. Okay, so then the transport layer actually forward this segment to the network layer, and network layer is considered whole segment, like the payload and header of the segment together as a payload, and it add its own header of, that means again the information about the network layer protocol, network layer process, right, all the information about this, and it is called the packet. Then the network layer forward this packet to the data link layer, and data link layer again take whole packet and consider the whole packet as a payload for the data link layer and add its own header, and together it call it a frame. And then the data link layer actually forward this frame to the physical layer, and physical layer convert it to the 010101 binary value and forward it through the networks, through the internet, through the network devices. So this whole process in the sender, the Alex laptop, is called the encapsulation. That means every layer it added the header, and together it's create a PDU. So the PDU of the transport layer is the segment, PDU of the network layer is the packet, and the protocol data unit PDU in the data link layer is called the frame. So this segmenting or encapsulate called the encapsulation. So the one a transport layer create its own segment, network layer creates its packet, the data link layer creates its frame, so it's called the encapsulation. So the sender actually do the encapsulation. So now consider this segment or frame or the bits ultimately reach to the Alina's laptop, and so in Alina's laptop physical layer will forward this to the data link layer, and data link layer look at the whole frame and remove or strip off the header and forward it to the network layer. Same thing, the network layer again look at the packet and strip off the header and forward it to the transport layer. So then the transport layer again look at its segment and strip off the header and arrange or rearrange all the segment. When it receive segment 1, segment 2 and segment 3, it receive all the 3 segments, and then it send application layer all the 3 segment together, and the Alina now receive the message from its friend Alex, and Alina is now happy. And this process in the receiving side or the receiver side is called the decapsulation. So it gradually strip off or remove the header from every layer, and finally all the segment make together and then forward it to the application layer. So Elena now receive the message from Alex. So the sender side do the encapsulation and receiver side actually do the decapsulation or de-encapsulation. So I think this will help you to understand the whole process of the network layered architecture, why we need the network layer, and how actually it works, what happening in each layer, what is the PDU. So thank you everyone for watching the video.